I'd like to talk about section 1.3, which has to do with dimensional analysis. All right, so what does that mean? Dimensional analysis means looking at the dimensions of the variables that are in an equation and making sure that they make sense. So for example, if I tell you that distance equals velocity times time, in unit 1, we talked about, or section 1, we talked about length in meters, mass in kilograms, and time in seconds. So distance is a measure of length. All right. Velocity is length per unit time. I'll use a T here for time. And then T is also in time. So if we look at our units here, we have length and then our T, we can divide top and bottom, equals length. All right, so that's an equation that makes sense. If we expand on that equation, what do I want to look at? We could write that in the units instead of the dimensions. So let's look at that. If we were to look at the full version of that equation, we have position is the initial position plus the initial velocity times time plus 1/2 the acceleration times time squared. Let's look at it this time with units instead of dimensions. All right, so this time we would have meters is equal to meters plus meters per second times seconds plus meters per second squared times second squared. And again, we see that they all come out to meters. So the important thing is, while we can multiply different dimensions, you can only add the same dimensions. So that's just another check you can do while you're working through things, that the equations you're using make sense. Okay, I wanted to do one more. Oh, right. I wanted to talk about some of the derived quantities. So what about volume? Right? Volume is a length cubed, and the units for that would be meters cubed. And you could do it with area also. And I moved it before it was done saving. Meters cubed. The software is not cooperating with me right now. All right, so area is a length squared, and that would have units of meters squared. All right, so what if we want to talk about a different derived quantity? We haven't really talked about forces yet, but I'm going to do force. All right, force has units of newtons. M is for mass, that's units of kilogram. And acceleration is meters per second squared. All right, I guess this one doesn't make a lot of sense yet because we don't know that that's how newtons are defined. Newtons are actually defined to be the amount of force required to accelerate 1 kilogram at 1 meter per second squared. All right, so by definition, these units line up. I don't really have much more to add on dimensional analysis. It's a simple idea, but it's an important one. So many times in physics, if you can look at it and the dimensions work, then you're probably on the right track.